Communication system. So when we talk about communication, it is basically transmitting a message from one place to another place. Communication can be done in various forms, in the written format, in the oral format. Oral communication is much more easier because you can get on the spot replies to the communication that you have been doing. But written communication helps us to get a proof that the opposite person has said or intended to say some kind of things. So now there are some elements in communication, that is elements of communication system. This is an entire communication system, and what all is needed in this communication system is, the first thing is the communication source. Communication source is a person or an object or a device which is making the noise or which is trying to send signals, which is giving out information, is the communication source. This communication source is attached to a transmitter. This transmitter does the work of transmitting the signals, transmitting the voice data, transmitting the information to the user. Now what does the transmitter have? It has a message signal generator. Suppose now if you are communicating and you have given your output in the form of voice, but a transmitter will generate that voice and convert that voice into the signal generator. With the help of signal generator, it will convert your voice into digital signals. You also have a modulator in the transmitter. Modulator does modulation. The entire modulation concept is being explained in this chapter later. It's an amplifier. Amplifier is a device which amplifies the noise, amplifies the voice, amplifies the signal. What do you mean by amplify? Amplifies means amplification, that is increasing in the amplitude. It increases the amplitude. For example, if someone is speaking softly but you increase the amplitude of the signal, you can hear that person loudly and clearly with the help of an amplifier. Example of an amplifier is a mic. When singers sing, they sing in the normal tone, in the normal speed and normal volume. But with the help of the mic, their voice reaches to a great level, to a great extent. That is, the mic amplifies the voice signal. And the last thing is the antenna. After a transmitter, we have a channel. Channel is the base medium through which the transmitter will transmit the voice data. Transmitter is basically the range, the bandwidth, the medium through which the data will travel, the voice signals will travel, the information will travel. Moving on to the receivers, and we have a receiver. The receiver can be any device which has a demodulator. Demodulator does the work opposite of that to the modulator. Again, an amplifier. An amplifier is needed at the receiver because if the receiver does not receive the voice in the volume that he or she intends to get, with the help of amplifier they can amplify the received signals. And a transducer. Transducer is a combination of transmitter as well as a receiver. Finally, we have the user of the information, the person who will get the information and use the information. Transmitter. Again, we will discuss transmitter in a little detail. What does a transmitter do? It sends the signal. The signals are sent by a transmitter. It modulates by doing modulation. What do you mean by modulation? Modulation is carrying the signal from one place to a faraway place. From the source to the destination, the signal is carried as it is. Now, why the need for modulation? Why do you need modulation? Even the low frequency signals or waves need antennas of very large height. These antennas are almost impossible to build. It is impractical to build antennas of this length. Now this length, when we say this length, it is of a few kilometers. That is, you need a few kilometers of antenna in height to send low frequency signals. So if we want to send high frequency signal, that is out of option because you need few kilometers. That is as good as about 5 kilometers of antennas in length. The length we are talking is a few kilometers. Even the frequencies get mixed up. Even after doing all of these, the frequencies from the transmitters get mixed up, and the receivers do not get the clear voice that they need. Therefore, modulation is needed. Now, what is basically modulation? In modulation, let's understand modulation with the help of an example. So, over here, I have, let's say if I have an RJ radio jockey talking from some radio station, let's say 93.5 radio station. So over here there's an RJ radio jockey talking. So when you listen to your radio, you listen to the radio jockey, he is being talking in his normal voice, in his normal tone, in his normal volume. His voice is not increased. But from one part of the city to the entire different another part of the city also, you can listen to the RJ loud and clear. The RJ is not shouting on the top of his voice. There is no amplification done to his voice because you can hear his normal voice. So how does this happen? This happens with the help of modulation. What does modulation do? It sends big carrier waves. There are big carrier waves moving on. They pick up the normal voice, the normal tone of the normal signals which are being given out by the RJ. And they are being carried all over the city as they are, and they come to the listener's ears. Now when they come to the listener's ears, the listener's receiver will demodulate the modulated signal. When I say it will demodulate, it means removal of this carrier wave. Removal of the carrier wave is demodulation. Adding of the carrier wave is modulation. Removal of the carrier wave is demodulation. So while modulating, we will just take the signal, the original signal as it is. We will place it on big signals and let it go, let it travel throughout the entire city. And the demodulator, the person who is listening, the device of that person will just take only the original signal and remove the carrier signal. This is demodulation. So this is the entire concept of modulation. There are three types of modulations: amplitude modulation, frequency modulation and phase modulation. Changing the amplitude, that is changing the length or changing the volume of the signal. See, change in amplitude. This is my original signal, and over here in my amplitude modulation I have changed the amplitude, that is I have given the same signal a new form, that is increased in the amplitude. The second form is the frequency modulation. In this we change the frequency. Over here this is my original frequency, same as this, but I have changed the frequency. Over here my waves are appearing frequently, but on this portion and this portion they are not frequent. That means I have changed the frequency. Over here they are equally distributed, the frequency is equal. The third one is the phase modulation, that is change in the phase, that is shift in the phase by an angle theta. So over here we have a change in the phase, the change in the direction in which the signals will go, and that change will be in the form of angle theta. It will be shifting the phase by an angle of theta. Channel. Channel is any form, any medium through which communication takes place. The channel can be either wired or wireless. It can be either space communication, ground communication, sky communication. So the space, the stratosphere, ionosphere, the ground, everything will be in the form of a channel. A channel will have a range. The maximum distance between the source and a place up to which signal is received with sufficient strength is called as a range. For example, now if we communicate, so at some point of time you feel that the communication is not quite strong. This is because one or the other device has gone out of range. Therefore, we have a particular range in which the signals are strong and the signals can transmit, and that is the distance between the source and the receive, and it should be sufficiently strong. Bandwidth, the range over which frequencies in a signal vary, is called as bandwidth. It is basically the largest, it is basically the difference. Over here you will write the difference between the largest and the lowest bandwidth. So over here now when we say that humans can hear from 20 Hertz to 20k Hertz. So when we say this, that humans can hear from 20 hertz to 20k hertz, then this will be the bandwidth. That is the difference from between the largest and the lowest is known as the bandwidth. Receiver. So a receiver will have a demodulator and an amplifier. Demodulator will do demodulation. The transmitter, when transmits, it does modulation. So to remove the carrier frequency, demodulation is needed. So demodulation is removing the original signal back from the carrier wave. The carrier wave and the original signal are separated out. The carrier wave is not let into the device. Only the original signal, the original information or data in the form of voice is let into the device, and it has an amplifier. It helps in changing the amplitude of the signal. After receiving the signal, if the user of the information or the receiver finds that the signal does not have the strength required, the volume required, then it can be amplified by using an amplifier which is built in a receiver. Okay. Now we'll talk about two important terms. One is transducer and other is repeater. In transducer contains of two things. One is transmitter and one is receiver. Combination of transmitter and receiver is known as transducer. So the receiving device, if it can transmit back, then it becomes a transducer. Even the transmitter device, if it can receive back, it becomes a transducer. One device that can transmit as well as receive is known as a transducer. Moving on to repeaters. For example, this is my source of the signal, and the signal is moving on. After some point of time, after traveling a certain distance, the signal gets faded. It starts fading, and over here I have my receiver. So when my signal starts fading, I use a repeater. This repeater will bring the same signal back to the original signal, and then it will be received by the receiver. Okay, so now we'll see the different layers of the atmosphere through which communication can take place. The first one is the troposphere. So the waves come over here, get hit by the troposphere and go back. It is the nearest layer of air to the surface of the earth. It's 12 km long. Above that we have our ozone layer, which is consisted by the stratosphere. The entire stratosphere with the ozone layer is of 35 kilometers, above which we have mesosphere of 30 kilometers. The main layer which helps in the communication is the ionosphere. Now this helps in the communication because it contains ions. Now the name ionosphere is there because it contains ions, and these ions get charged when the sunlight is on them. So when the sunlight is on them, the ions will get charged. Therefore, the condition of this layer, the state of this layer will be different in the morning and at night because it depends on the sunlight. Okay, now this ionosphere consists of three layers. First one is thermosphere, second one is Kennedy heaviside layer, third is the Appleton layer. All these consist and form together ionosphere. Is a streak 20 kilometers long. This is the main layer used for communication. It contains of D, E and F layers, that is the thermosphere, Kennedy and heaviside. But at night the D does not exist. So this is D, this is F1 and this is F2. So at night the D does not exist. The D disappears. F1 and F2 merge to form F. So at night we have only two layers, that is E and F, but in day we have three layers, D, F1 and F2. Now when we talk about the types of communication, there are two types of communication. One is ground wave propagation and the second one is sky wave propagation. In the ground wave propagation, this is a data which moves from the ground with the help of the wired systems, but this is a very unreliable sort of communication. Even the strength of the signal is very weak, and there may be chances of noise entering into the wires. Therefore ground wave propagation is not generally used, but it is quite effective where the distance between the source and the destination is very less. Otherwise we use the sky wave propagation where the source will send its waves to one of the spheres and then it will go back to the destination. This is my sky wave propagation. When we talk about electromagnetic waves, the names that come to our mind are microwaves, radio waves, ultraviolet radiations, X-rays. Visible light radiation. What do you mean by visible light radiation? The sunlight, the waves that come from the sun. This is my sun. These are the electromagnetic radiations which reach the earth, and this is the atmosphere of the earth. So these waves are also electromagnetic waves. Electromagnetic waves do not need any medium for traveling. Infrared radiations are another example of electromagnetic waves. So what is an electromagnetic wave? An electromagnetic wave is a wave radiated by an accelerated charge and which propagates through space as coupled electric and magnetic fields oscillating perpendicular to each other and to the direction of the propagation of the wave. So electromagnetic field, as the name suggests, electro and magnetic, will consist of two things, the electric waves as well as the magnetic waves. This is my electric field and this is my magnetic field. So it propagates, and both of them should be perpendicular to each other in the direction of the propagation of the wave. So if this is the direction of the propagation of the wave in this way, so if this is the direction of the propagation of the wave, then this will be my electric field and this will be my magnetic field and this will be my direction of propagation. All the three will be perpendicular to each other. Okay, now for solving sums, there are different formulas which will be used. The first one is Maxwell showed that the speed of an electromagnetic wave in free space is given by C is equals to 1 upon root mu naught epsilon naught, where mu naught is the permeability of free space and epsilon naught is permittivity of free space. If it is not traveling in free space, it would be mu epsilon, when mu is the permeability of the medium and epsilon is also the permittivity of the medium. Intensity of an electromagnetic wave is given by energy by time upon area. In other words, it is power by area. And velocity is given, the another formula for velocity is E naught upon B naught. As we all know, electromagnetic waves are made up of two components, electric field and magnetic field. So E naught denotes electric field, B naught denotes magnetic field.